Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hidayah binti Syahri. Today I will be presenting on my final year project with the title Development of Iron, Cobalt, Nickel, Aluminium, Boron, Silicon, High Entropy Alloy for Catalytic Application in Degrading Azodite. I'm being supervised by Dr. Nur Hidayah binti Nurdin. So for my presentation today consists of 5 parts, which is Introduction, Problem Statement, Solution Proposed, Objective of Study, Methodology, Result and Discussion. So let's get started. As we know, there are many kind of color that we can see around us, such as purple, pink, blue, orange, white, and many type of colors. However, did we ever think to one question, where this color come from? To answer to this question, the answer is they are using some of coloring that we call as azodite. Azodite is a synthetic organic dye that contains nitrogen as an azo group, and this azo function is often linked to an aromatic ring, and the color can be broken down to an aromatic amine and arylamine. And this azodite being used to give colors to the textile fibers such as cotton, wool, and many type of textile fibers. And there are examples of azodite being currently used, such as 4-amino benzene, metal orange, and direct blue 6. And also, this azodite being used in many kind of applications, especially in the textile industry, pharmaceutical industry, food industry, and production industry, in order to give a very colorful product to attract people. However, this azodite having a problem as it can give effect to the environment and human being, and also even though there is a current methodology that being used, this methodology having a deficiency due to a poor catalytic activity. So let's see how this azodite can affect the environment and human being. This azodite can affect to the environment as it can produce a very dangerous substances known as aromatic amine that can give a carcinogenic effect to the human, and also it can diminish the photosynthetic activity of the aquatic animal that might disturb the ecosystem of the aquatic animals. And moreover, this azodite can disturb the COD and BOD by increasing the acidity and base toxicity. And lastly, this azodite also can hinder the photosynthesis process at air-water interface, and it can prevent the self-purification of the soil. Due to this, there are some current methodology. However, this current methodology having a lot of deficiency in terms of the cost, in terms of the kinetic reaction, in terms of the catalytic reaction, as all of this can affect the azodite production. Due to these all deficiencies, we propose a solution in order to develop a iron, cobalt, nickel, aluminium, boron, silicon, high entropy alloys powder in degrading azodite, with 3 main objectives in the study to develop a iron, cobalt, nickel, aluminium, boron, silicon, high entropy alloy powder as catalyst by mechanical alloying. And this powder will be characterized by SAM, FIR, and XRD. So let's tell you what is high entropy alloy. High entropy alloy is an alloy that contains multiple elements, 5 or more, in equiatomic or near equiatomic ratio and minor elements. And this alloy has a high mixing entropies of solid solution phases, enhance their stability by 4 core effects that contribute to the magical properties of the material as catalyst. Even though this alloy consists of 5 or more elements, it still can form a very simple crystal structure such as polycentercubic FCC, fixed centercubic FCC, hexagonal closed pack SCP. And how this entropy alloy can still form a very simple crystal structure? This is by referring to a heat-free energy of mixing delta G mix equal to delta H mix minus T delta S mix. This configuration entropy of a system is the number of ways in which the atom themselves can distribute in the space. And with the higher number of elements would potentially lower the mixing free energy, and by having a lower the mixing free energy, it can form a very simple crystal cubic such as FCC, PCC, and HCP. And so, this also being contributed to due to a four core effect, which are high entropy effect, severe lattice distortion effect, sluggish diffusion effect, and cocktail effect. And this effect can give a very good impact to the alloy, as it can reduce the thermal effect on the properties and increasing the hardness. And secondly, it all due to the sluggish diffusion effect, which is greater number of elements with lower diffusion rate, and it can give an easiness to get supersaturated state and fine precipitate, and also increase the recrystallization temperature. And more than that, it also have a cocktail effect, which is emphasize the enhancement of the properties by at least 5 major elements, which means we can control the amount of the element in order to get the phase that we want, such as FCC, FCC plus BCC phases, or BCC phases only. So, in this study, we're using 6 different elements, which are iron, cobalt, nickel, aluminium, boron, and silicon, with different kind of properties. And these properties be considering in terms of the cost, as iron is the most cheap catalyst that can be used in the production. And for the cobalt and nickel having a very good ferromagnetic properties, and aluminium also have a very good recyclability, which means we can use it repeatedly. And lastly, for the boron and silicon, we have a very good properties in terms of the resistance to heat and non-toxic. And the most important thing is it is low cost. So, how this high entropy alloy being produced? So let me see the metallurgy. The metallurgy being separated by two parts, which is for the sample preparation and the mechanical alloying. For the development of high entropy alloy, it consists of first step, which is sample preparation. For the sample preparation, the metal powder was weighed and the total weight is plus minus 3.5 grams. And then the metal powder was mixed with PCA alcohol with 1 gram. The mixture of metal powder and the PCA alcohol then will be mechanically alloying. In the mechanical alloying, we are using planetary ball milling, and the ball to powder ratio is 5:1, and the quantity of the ball used in this study is 3. And then the parameter is being varied due to their time, which are 50 hours, 60 hours, and 70 hours respectively. And after that, all the sample will be characterized by SAM, SRD, and EDS in order to see the properties of the sample. So let me discuss on the result and discussion. For the result and discussion, firstly, for the first analysis, which is phase analysis, by referring to the figure 4.1, which is SRD pattern of iron, cobalt, nickel, aluminium, boron, silicon, we can see that there is just only one single peak that exists in this graph, which means that the HEA powder are completely alloyed. As we increasing the time of the milling from 50 hours to 72 hours, the peak appeared to be more sharp and fine. This shows that the powder have been mixed homogeneously with each other. However, by referring to the figure 4.2, we can see that there are some elements that are not mixed in the same peak at the single peak, which are silicon, cobalt, nickel. However, the value for each of the element is quite low. Secondly, for the morphology analysis, the surface of the powder is rough with many coagulation and microspore, and these microspore have been measured by using ImageJ software, and the average size of the microspore is 1.8723. The number of microspore is higher, exhibit that these powder are relatively uniform distributed with each other on the surface of the powder. However, by referring to the figure 4.4, we can see that an agglomeration occurs. This agglomeration occurs due to the unstable type of PCA. So, this agglomeration can affect to the powder composition. Next, by analyze the ADS analysis, we can see that the particles are composed of iron, cobalt, nickel, aluminium, and silicon. However, we can see that at the region 2, the composition of iron is quite high at 22.46%. This occurs due to the agglomeration at that region. This agglomeration can increase the percent of iron in the alloy. However, by referring to the region 3, we can see that the value of the composition of element is nearly equal atomic percentage in good agreement with the nominal composition, which are 0.27 for iron, cobalt, nickel, and 0.1 for aluminium and silicon. And lastly, this is the experiment setup that can be done in order to test the azodide solution with the catalyst of high entropy alloy. The equipment and material that being needed in this experiment is mechanical sterile, beaker, metal orange as a azodide solution, and redox stand. However, the experimental setup cannot be done for this semester due to time limitation. As a conclusion, we can say that the development of high entropy alloy can be done and accomplished by mechanical alloying. And this new metallic material as catalyst for azodide degradation can contribute to treat the wastewater treatment in order to achieve one of the SDG goals, which is to ensure the access to water and sanitation for all. However, we as a Muslim, we need to hold a responsibility to take care of our environment from being polluted or being damaged. By that, thank you. Assalamualaikum warahmatullahi wabarakatuh.